Somewhere in the cold silence of interstellar space, a small, quiet traveler is still moving. It was built to study distant planets over a handful of years, but it ended up outlasting its creators and drifting far beyond the edge of the world that made it. It began with a rare geometric alignment that comes around roughly once every 175 years. The outer planets lined up in a specific sequence, meaning a single spacecraft could visit several worlds in one continuous trajectory, using each planet's gravity to sling itself toward the next. Scientists call it a gravity assist. The spacecraft steals a tiny fraction of a planet's momentum and converts it into speed. This rare window made it possible to reach the furthest reaches of our solar system in years rather than decades. Voyager 1 launched in the late summer of 1977. On board was a modest suite of instruments, cameras, spectrometers, and magnetic field detectors built to measure the harsh radiation filling the space between worlds. At the time, humanity was only just learning to reach its nearest planetary neighbors. No one imagined these machines would work for decades beyond their planned lifetimes, or that they would eventually become the most distant objects ever built by human hands. Voyager's first great destination was Jupiter, a world of storms and lightning. Its cameras captured chaos on a planetary scale, including the Great Red Spot, a storm 16,000 kilometers wide. Our entire planet could disappear inside it without a trace. As Voyager flew past the moon Io, it recorded something witnessed for the first time in history: active volcanoes on another world. Some plumes rose over 100 kilometers into space. It proved that even a moon lost in the icy cold far from the sun could be heated and melted from within by a planet's crushing gravity. Saturn appeared next. From Earth, its rings looked like smooth, glowing bands. Up close, Voyager revealed their true nature: countless individual ringlets and waves made of icy particles, ranging from tiny grains to massive chunks, all sculpted by the gravity of nearby moons. The spacecraft then targeted Titan, a moon larger than Mercury. Wrapped in a thick nitrogen atmosphere, Titan acts as a frozen laboratory, running chemical processes that echo the environment that may have preceded life on Earth. In 1990, Voyager turned its camera back toward the inner planets one final time. From nearly 6 billion kilometers away, it captured Earth as a tiny point of light, the pale blue dot. This photograph provided a merciless perspective on our place in the cosmos. Every empire, every war, and every life ever lived happened on that single pixel, suspended in a random ray of sunlight. Ahead lay the heliopause, the boundary where solar wind pressure is matched by interstellar material. On August 25, 2012, sensors recorded a sharp drop in solar particles and a rise in cosmic rays. A human creation finally entered the void between stars. Voyager is now so distant that light itself takes nearly an entire day to reach it. A command sent today arrives tomorrow, and its reply won't reach Earth until the day after. Every conversation with this traveler now stretches across days. Its power comes from generators that convert the heat of decaying radioactive material into electricity. But that output inevitably declines. Every year, there is less energy available, forcing the spacecraft to shut down one system after another to stay in contact. To catch its near imperceptible whisper, Earth uses antennas the size of apartment buildings. It is a massive engineering effort to hear a signal trillions of times weaker than an ordinary light bulb, buying the probe another year or sometimes just another month of life. One day, the power will fall below the threshold required to transmit. From Earth, its departure won't look like a sudden event. One day, the machine will simply stop answering our calls, and Voyager will become a silent wanderer in the dark. Attached to the spacecraft's body is a gold-plated copper disc, the Voyager Golden Record. It was designed as a physical artifact that would survive long after the electronics have failed. Etched into the cover are instructions for playback, and a map showing our sun's location relative to nearby pulsars. It carries the sounds of Earth, whale songs, bird song, and thunder, alongside music and greetings in 55 languages. It is a message in a bottle thrown into an ocean the size of the universe. It carries a compressed self-portrait of all humanity into a distant future where we ourselves may no longer exist. Curiosity. In roughly 40,000 years, Voyager will pass within 2 light-years of another star. Because the distances between stars are so immense, even a spacecraft traveling at 17 kilometers per second is in effect almost motionless. Nothing we build on Earth lasts forever because of air, water, and erosion. But in the frozen emptiness of space, there is nothing to destroy the probe. It will remain our most durable monument, more lasting than any pyramid or cathedral ever carved in stone. Billions of years from now, our neighboring galaxy, Andromeda, will merge with the Milky Way. Gravity will reshape everything as the 2 galaxies pass through one another and slowly merge into one. Despite the scale of this collision, the stars themselves won't crash into each other. The distances between them are too vast. Voyager will likely survive this encounter intact, finding itself reshuffled into a new, single galaxy born from 2. Long after our sun has gone dark and Earth has been erased by time, this machine will still be moving through the dark. It will be older than almost every star that has ever burned in our galaxy. To grasp the scale of 10 trillion years, try compressing the history of the universe into a single year. All recorded human history would fit into the final few seconds. 10 trillion years is 1,000 of those years stacked end to end. By that point, the era of bright stars will have ended. Only the smallest red dwarfs will remain, until they too burn out, giving way to an endless night. All that will remain are black holes and dead suns scattered through the darkness. One possibility is that matter itself eventually decays. Over unfathomable time, atoms may dissolve until everything that ever existed vanishes. If Voyager survives that long, the universe itself will eventually begin erasing it, particle by particle. Until that final horizon, Voyager will continue its silent journey. It is a mute piece of metal that serves as the final proof that somewhere, in the freezing emptiness of space, life once reached out toward the stars.